Today we are going to discuss analytic function of a complex behavior variable. Function is said to be analytic in both condition if it satisfies the both condition, that is continuity and differentiability. But it can't be 100% sure that if function is continuous and differentiable, it is going to be analytic. But vice versa is true, that is analytic function is definitely continuous and differentiable. So if we prove that a function is differentiable, so we can say that it can be analytic. To check the analyticity, we should the scientists Cauchy and Riemann give an equation that is called Cauchy-Riemann equation to satisfy the function is analytic or not. Here, to prove this equation, we simply consider a function that is f equals to u plus iv, which contains both real and the imaginary part. First, we have to check the function is differentiable or not. So we check by writing it here. We have this. So we can write the function is z plus del z form. That is u. We simply add the del z variable. That is, we can write u plus iv plus del u plus del iv. Okay, sorry, my del is here. We can write is u plus del u plus iota v plus del v. This is the function we get. Check the differentiability. We should just differentiate. We should just minus it with the function of fz and differentiate with the smallest term, the smallest variable, that is del z. So we can write it like del u plus del u plus I v plus del v minus, for fz, you know that fz is nothing but u plus iv and divided by del z. Okay, so here u plus iv just cancel out with the u plus iv in the minus term. So we simply get del u plus I del v by del z. Here we simply get a differentiable function. Now we check if this function is differentiable or not for both the axes x and y. We write both axes in simple term. First we check for the x-axis and second we check for the y-axis. If it is satisfied for the both condition, we simply say that the function is analytic. We derive this in the next part. Thank you.